Well, we have our review for Chapter 1 test, and I wanted to start off with a couple of the properties because those are the things that sometimes people often forget about during a test. So one thing you want to make sure is that you have all of these memorized and know exactly how to explain them. Commutative property means simply that things have moved. AB is now BA. The associative property is just that there's been a change in grouping. A and B are grouped together. Now over here, B and C are grouped together. And same thing with the multiplication. AB is grouped together. Now BC is grouped together. For addition and multiplication, that has no effect on the evaluation of the equation. So simply, it's just grouping has changed. The identity property, pretty easy to remember. The addition identity is that you're adding 0, so A plus 0 equals A. In other words, nothing happened when you added 0. Same thing with the multiplicative identity. When you multiply 1 times A, nothing's happened. Still remain A through addition and through multiplication. The inverse property for addition, in other words, adding the opposite will get you to 0. And for multiplication, the inverse, very helpful when simplifying fractions, is that when you multiply something by its reciprocal, it's going to equal 1. And 1 is a very powerful number, believe it or not, in mathematics. A quick example would be, suppose I wanted to take 3/7 and multiply it by its reciprocal, 7/3. That is going to equal 1. And that's a way to eliminate fractions. The next one here is going to be the ideas of, the distributive property, where you're simply multiplying A through your parentheses to get A times B plus A times C. This might look familiar. I believe we had a problem like this in the homework, Ry minus Sy, and we wanted to get Y by itself, I believe. So let's just say we had this equation, Ry minus Sy equals H. We can do the distributive property in reverse and, in essence, factor out this Y. And then get Y by itself by dividing both sides by R minus S. The other items you guys should probably know by definition are the ideas of the real numbers. This whole diagram are all the real numbers. From here all the way over, these are all the real numbers. The easiest basic number set is the natural numbers. These are the counting numbers. Whole numbers are just the counting numbers with 0. Integers are the positive and negative whole numbers. And rational numbers are numbers that can be written as a fraction and whose decimal values terminate or repeat. And those definitions are right down here. Irrational numbers, in other words, the other half of rational numbers, if you will, are numbers that cannot be written as a decimal because they do, or can be written as a decimal value, but they do not terminate nor do they repeat. A prime example would be radical 2. You can see that the decimal value here does not repeat and does not terminate from the dot, dot, dot. Excellent examples are anything with a radical is a good idea that it might be an irrational number, and pi. However, be careful with the radicals. What about radical 9? Is that an irrational number? No, because it can be simplified simply to 3. You might want to remember that. Let's take a look at some other key vocabulary words. We had several here to work with. One was evaluate, like terms, a solution of an equation, and equations and inequalities. To evaluate, remember what word is inside evaluate? This word right here, value. In other words, we're looking for a value at the end, because all we're doing is plugging in this value in for this x, and for this x, right here, oops, and for this x. And here's what it's going to look like when you plug those in. Then simplify using your PEMDAS. We also talked about when we are solving an equation, we do the PEMDAS in reverse. SADMEP. So here's an example of SADMEP. Suppose we had 3 times the quantity x minus 5 plus 10 equals 3. Well, let's just make it 6, whatever. So to get this x by itself, in other words, solve for x, we have to do a couple things. First, we're going to have to go ahead and pick off this 10. Again, we're doing SADMEP in reverse. Subtract 10 from both sides. Then we can go ahead and divide both sides by 3. And then our final step is to add 5 to both sides. Now, to simplify this a little bit further, remember 5 can be written as a number with 3 as its denominator. If you think about it, that's going to be 15 thirds minus 4 thirds. That's going to leave you with x equals 11 thirds. So it's kind of like a combination of using SADMEP and PEMDAS to solve for one equation. The last section we had was looking at equations and inequalities involving absolute value. And we said absolute value is the distance a number is from 0. So let's take a look at this problem that they have here. First thing I always ask you guys is whether or not is your absolute value isolated. And this one is. There's nothing out front and there's nothing in the back here, so it is isolated. Now, since it's isolated, we have to split it up into 2 problems. Drop the absolute value here and drop the absolute value here. Remember to take the opposite here. Simplify, subtract 2x from both sides, get the constants on the other side, x is going to equal 9. Here you're going to go ahead and distribute the negative to change all the signs, that's fine. Then add 2x to both sides, then add 5 to both sides, and solve for x. Remember, when you have absolute value problems, you really have 2 problems. All equations are OR statements. And if an inequality starts off with greater than or equal to, we know that it's going to be greater in other words, an or statement. And if it's less than or equal to, we know it's going to be less than. In other words, an and statement. And we said and always means overlap. So when you're graphing an and statement, you're looking for overlap. So if you want to go ahead and give yourself a little bit extra practice, which obviously sounds like a good idea, is that if you wanted to try page 52 in your book, and 10 through 34 are excellent practice problems for the exam, for your test. And any of these you need to practice. If you want to practice them all, that's fine. If you want to practice just the ones you need to, that's fine. But all the answers are in the back of the book. Good luck on your test on Tuesday, and I look forward to seeing you in class.